Hello everyone! Today, I'm going to be taking you through an in-depth look at our versatile lineup of metal fabrication products, which include fiber lasers, conventional and high-definition CNC plasmas, and Waterjet cutting systems. As all three of these cutting technologies have the ability to produce quality cuts on many of the same materials, we will be providing you with a direct comparison of each technology to help you better determine the right machine for you and your fabrication needs. Before any purchase, we like to ask our customers a few questions. First, why do you and your company need a CNC cutting machine? Are there any bottlenecks in your manufacturing process? Do you currently have any post-processes? And is there anything in terms of capabilities that you would like to add to your process? As we discuss each technology, ask yourself these questions, and by video's end, you should have a firm grasp on which CNC solution best fits your needs. Let's first start our discussion with Waterjets. Waterjets have some really interesting cutting capabilities and are part of the cold cutting processing category of machines. There are zero flames, arcs, or light sources that generate heat to cut the material. Instead, it mechanically erodes or shears through the material with the use of high-pressure water and abrasive. In doing so, the material doesn't have any heat-affected zones in the areas where the cutting has taken place, unlike the other two technologies that we will be discussing today. But the greatest benefit of cutting with the Waterjet is the fact that it's much easier to list the materials that a Waterjet can't cut than the materials that it can, as there is almost no limit to what a Waterjet can cut through. Let's now take a look at plasmas. Plasmas are divided into two categories, conventional and high definition. And in stark contrast to Waterjets, plasmas are defined as thermal or hot cutting tools. Plasmas work by sending gases from the center of the torch towards a piece of conductive material, and as it does, an electrical arc between the torch and material is created. As the gases flow through the constricted opening of the torch, the heat of the arc changes the state of gases to superheated electrically ionized gas or plasma that slices right through the metal material. This method is very efficient for cutting medium to thick materials and can be 2 to 10 times faster than other technologies on the same materials. Lastly, we've got fiber lasers. Fiber lasers first came to market in the 1980s and use light that is emitted from a power source which travels inside a special cable. At the end of that cable, a cutting head is attached, which then focuses the light until it generates enough power for it to cut through metal like magic. Because of its ultra-high cutting speeds, low operating costs, and ever-increasing capabilities, fiber lasers have recently found a large home in the metal processing industry. The mindset of many fabricators has been altered from thinking of fast cutting as 100 to 300 inches per minute to now cutting at 1,000 to 3,000 inches per minute, or 16 to 50 inches per second. As higher wattages are developed and motion platforms advance, speed will soon be the only thing that matters, and everything else will be left in its dust. Let us now look at these four pieces that were cut out of mild steel on each of the four types of machines. This first one was cut on our V-Series Waterjet at 55,000 psi, and as you can see, there has been no molecular changes in the structure of the material due to its cold cutting process, which has eliminated any need for secondary grinding, polishing, or other post-cutting processes. We used a kerf of 3/100 of an inch, allowing for some very detailed cutting, but unfortunately, this amount of detail and the elimination of post-processing doesn't come without a price. Waterjets have a higher operational cost than conventional plasmas and fiber lasers, and are also much slower when it comes to cut time versus the field. Next, let's take a look at this part cut on a conventional plasma. This was cut on our iPlasma model, which is a very easy to learn entry-level system that can also be equipped with additional handheld attachments. These attachments can make removal of material skeletons easier by providing you the ability to manually cut them into smaller sections. We used a Hypertherm PowerMax 85 at 85 amps with an air-air process that resulted in a smooth edge with minimal dross. Having a low to medium operational cost, this type of machine is great for those who are cutting metal art or who have a custom job shop that need a plasma with a small footprint. If you are currently cutting steel by hand, it might be time to make an upgrade, as the iPlasma can do all of this with just a click of a few buttons. Now we have our part that was cut on a high-definition plasma. Our 3000 series plasma used a Hypertherm XPR power unit with true hole technology, or non-beveled hole technology, at 170 amps and using O2 air, which as you can see resulted in this part being cut with an amazingly high cut quality and with little to no dross. Simply put, this technology is perfect for those needing the best cut quality a CNC plasma can offer, giving its users a quick cutting option that provides clean edges with minimal post-processing. Our last piece here was cut on our Quantus fiber laser system, using a curve of 29 thousandths of an inch at 4,000 watts and with O2 gas. The small curve size allows you to achieve the highest detail of any of the thermal cutting processes, and also results in a very minimal heat affected zone. The fiber laser also offers the lowest operational cost for thermal cutting over linear distances. If you're looking to cut mild steel, stainless, aluminum, copper, and others, for such industries as HVAC, aerospace, automotive, and oil and gas, then adding a fiber laser to your workflow might just be the right solution for you. Here at MultiCam, we have the unique advantage of manufacturing all of these cutting technologies right here in our manufacturing facility in Dallas, Texas. Our goal is, and has always been, to provide you with the best CNC solution for your application and business needs. If you currently have any bottlenecks or post-processes you're looking to eliminate, or are interested in broadening your fabrication capabilities, be sure to give us a call at 972-929-4070 or visit us on the web at www.multicam.com and request a demo today. We provide both in-person and virtual demonstrations. Thanks for watching, and be sure to like this video and click subscribe on our channel to receive more great content like this.